Welcome to Conditional Probability. So today we're going to learn about a different type of probability. So first thing, what is conditional probability? Conditional probability is the probability of an event occurring given that another event has already occurred. So what you're going to see is now the word given that instead of and or. So how you figure those out is you have the probability of both of the events together over the probability of whatever is after the words given that. So let me show you what I mean. So it says Naomi is playing a game with a spinner with 8 equally sized sections as shown. What is the probability that the spinner lands on 7, given that Naomi has spun a number greater than 5? So what we're first going to do is we have to figure out the probability that it's greater than 7 and that it's 7 and greater than 5, because that's the two probabilities it talks about. And then the probability of whatever is after the word given that. So it says a number greater than 5. So on bottom, your probability is of the number greater than 5. So the probability of 7 and greater than 5 is 1 out of 8, because 1 is greater than 5. So 1 out of 8 of these. And then the probability of it being greater than 5, we have 3 numbers greater than 5 out of 8. Now, if you remember, when you divide fractions, you take the bottom fraction, you flip it upside down. And when we do this, we can cancel out both of those 8s. So it actually reduces to the fraction 1/3. But if you notice, the 1 is how many of these numbers over here are 7 and greater than 5. And on bottom is how many are actually greater than 5. So I figured that's the easier way to figure out our conditional probability, is instead of thinking probability as fractions, is we think of them as a number. So here's our next example. A single 6-sided die is rolled one time. Determine the probability that a 2 was rolled, given that an even number has been rolled. So now, to think of it, we want the number of how many of these are 2 and even over how many of them are even. So on a die, of course, there's 1, 2, and there's 3 evens. So then our probability ends up just being 1 out of 3. So it's just how many 2 and even, and how many even. Let's go on to another example. Now we are going to be given some numbers in a table. We want the probability a student plays lacrosse given that the student is a junior. So again, we need to set it up in words. It makes it easier. So we want the number of lacrosse and junior, because those are the two categories we're talking about. And then the word after given that is junior. So we want the number of junior on bottom. So my number of lacrosse and junior, so I go over to where it intersects here. Lacrosse and junior is 34 over the number of juniors. So I'll just have to add up how many juniors. So there's 34 that were lacrosse and junior, 544 that were total juniors, and that will reduce to 1 over 16. One reminder on the reducing, if you have the fraction button on your calculator, all you have to do is do the 34 ABC 544, push equals, and that'll reduce the fraction for you. Let's do another example of this. Michaela is in Algebra 1, given that she is a freshman, so we want that probability. So again, in words, it's the number that are in Algebra 1 and a freshman over the number of freshmen, because that's what's after the word given that. So the number of Algebra 1 and freshmen would be 96. And then we need to total up our freshmen to figure out what's on bottom. So we had 96 that were Algebra 1 and freshmen, and then 139 total freshmen, and this fraction does not reduce. So this is our answer. That's it for conditional probability.